Now coming to the production of the ultrasound. Now the thing is, with the tuning fork we are producing these waves and everything, but however that waves are not useful for therapeutic purposes. We need higher waves, higher frequency waves. So in order to produce these high frequency waves, what we do is we use these generators for therapeutic purposes. Now how is this ultrasonic waves actually being produced therapeutically? Now the principle behind the production of the ultrasonic waves is reverse piezoelectric effect. What is reverse piezoelectric effect? Now to know about the reverse piezoelectric effect, we should first know what is a piezoelectric effect. What is a piezoelectric effect? So when you take a crystal, the crystal can be any crystal. You can take a quartz crystal, you can take a nickel cobalt ferrite crystal, anything. Okay, usually a quartz crystal is preferred. This is because it's commonly valuable and also it is not as expensive as the remaining crystals. Okay, so when you take a crystal and when you actually send mechanical waves through the crystal, see, this is a crystal. Now I am sending mechanical waves. Now when these mechanical waves pass through the crystal, what happens is there will be this potential difference that occurs in the crystal, and the shape of the crystal will deform, it will change its form and it will produce electrical waves. I hope you are understanding. So we have taken a crystal and from the crystal we have sent these mechanical waves. Now when we are sending the mechanical waves through the crystal, what is happening? There is this potential difference occurring, and because of the potential difference the crystal gets deformed and it produces electrical waves through the crystal. Okay, this is called as piezoelectric effect. Now what is the reverse piezoelectric effect? The reverse piezoelectric effect is completely opposite to that of the piezoelectric effect. That's why it's called as reverse. Okay, so we have a crystal again. Here we'll send electrical waves. Maybe we'll send a high frequency currents. Okay, when the electrical waves are sent through the crystal, what will happen? Again the potential difference will happen, the crystal will change its form and it will lead to the production of mechanical waves. Now what are these mechanical waves? These mechanical waves are the ultrasonic waves that we are talking about. Okay, so that is the reverse piezoelectric effect. We have taken a crystal, we have subjected it to a high frequency current, and what will happen? From the crystal we will get the mechanical waves, which are the ultrasonic waves. Okay, that is the principle on which the ultrasound machine works on. Okay, now here is something we have to remember. Let's just assume that this is our ultrasound machine. Okay, this is the actual unit, this one right over here, this is the unit. Okay, if 1 megahertz is produced in this unit, then obviously 1 megahertz will be emitted out of the head of the ultrasound. This is the head of the ultrasound. Okay, if you are like actually producing a current of 1 megahertz in the actual unit of the ultrasound, obviously the head will also emit the equal amount of ultrasound out. Okay, and the crystal that we have mentioned earlier, it will be present in the head. Okay, it will present here. The crystal will be completely molded in a metal. Okay, it will be not exposed outside, it will be present inside the head, molded in a metal. Okay, so that is something you will have to remember. Whatever the current is being generated in the machine will be the same amount of the ultrasonic waves that will be produced out of the machine. Okay, fine. Now there is something which is called as passing of ultrasonic waves in different mediums. Now what is this? We'll go with the same example, our basic physics example, which is the low velocity medium and the high velocity medium. So let's just take two mediums. This is air, okay, and this is our water. Okay, so whenever you're giving ultrasound in an angular manner, like you're not giving it straight but you're giving it in an angular manner, what happens is, see, this T over here is our target tissue. Okay, this is the target tissue. I will color it in pink. Okay, this is the tissue that we are supposed to treat. Now what actually is happening over here is, I am giving ultrasound, I am placing the ultrasound in an angular manner. Okay, I am placing it like this in a cross manner. So what actually is happening here? Actually, when I am placing it here, the waves are supposed to come like this. But what is happening here is, because of the difference in the mediums, the waves will come in a different area. Okay, they are getting deflected. Okay, the waves are getting deflected. Okay, see, this is the angle of inclination over here and this is the angle of deflection. Now usually the angle of inclination and the angle of deflection should match. See, this is the angle of inclination and this is the angle of reflection. Okay, the angle is the angle of inclination and the angle of reflection matching? No, here the angle of reflection is higher. This is our target tissue, but because of the difference in this media, what is happening actually, the angle is shifting, okay, shifting laterally. Now here the treatment is being given, but is it actually useful to treat the area over there? No, we have the problem over here. The problem is over here. Okay, and the treatment is being given over here. So what will happen? It's just waste of treating the patient because the condition will not be resolved, and also there is this wastage of the ultrasonic waves that are being produced by the machine. Okay, so whenever you're treating a patient, make sure that you're placing the head perpendicular to the area whatever you're treating. If your treatment area is this, place the head straight on the top. Don't place it in an inclined form, so that the angle of reflection will change and the treatment or the ultrasonic waves will be transferred to a different area that you're treating. Okay, so that is very important. So whenever you're treating a patient, always make sure that you're placing the head perpendicularly to the area you're treating. Okay, next we have the attenuation of ultrasound. Now what is attenuation of ultrasound? So whenever you're treating the patient with ultrasound, when the beam, the ultrasonic beam comes out of the head of the transducer and it enters into the tissue, what actually happens is, at a point the intensity will be reduced, and this reduction is called as attenuation. And why actually this attenuation is happening? It is happening because of two factors, which is absorption and scattering. Okay, now what is absorption and scattering? So absorption is, as we have already mentioned, different structures in the body absorb the ultrasonic beam with different frequencies, we can say. Different structures in the body absorb the ultrasonic beam. As I have mentioned earlier, the bones absorb a greater amount of ultrasonic beam compared to that of the fluid filled structures like blood. Okay, so whenever you're treating a patient, remember that the absorption will be present within the tissue, so there will be decrease in the amount of the ultrasound as it goes in the body. Okay, and the next one we have is scattering. Now what is scattering? When the area constitutes of bubbles or particles, what actually happens is there will be deflection of the ultrasonic beam, which is called as scattering. Okay, so because of these two factors, there will be decrease in the ultrasonic beam as it goes deep into the body, and this is called as half value distance. Okay, so this decrease in the intensity of the ultrasound from the beginning as it goes into the deeper tissues is called as half value distance. Now if you are giving 1 megahertz, then the half value distance would be 4 centimeters, like it can go up till the 4 centimeters. Okay, if you're giving 3 megahertz of frequency, the half value distance is 2 centimeters, that is the depth of penetration will be till 2 centimeters. Okay, that is half value distance.